Hi, and welcome back to my series on how to use Microsoft Excel with NVDA or non-visual desktop access. In this video, I'm going to discuss and demonstrate some essential commands and procedures in finding measures of descriptive statistics. Uh, these are measures of central tendency and measures of variability. So to get started, I have already opened a workbook, and this is entitled uh, data. So these are data from a survey, and I have here two variables: weight and height of the respondents in the survey. So I'll walk you through first of some of the uh, locations in this worksheet. So on cell A1,
Survey 1.
so here's a label, survey, and going down,
Respondents cropped A2.
I have respondents, and this is a column header on A2, and on B2 I have
Width B2.
weight
Height C2.
and height on C2. And under each column header, particularly for weight and height, I have some data here, around 70 plus data. Now I'll go to A78. I'll just make use of the go to command.
Go to dialog. Go to reference. Edit Alt R blank. A 7 8. A 7 Microsoft Excel data XLSX sheet 1 table frequency count overflowing A78 respondents.
Now the first thing that I will be computing is the frequency, or the frequency count for each column. So I'm going to find the frequency of the weight and the height. So I'll press tab to go to B78.
B78 weight.
Here, to find the frequency, I'll make use of the count function. So here I'm going to input equals count, that's COUNT, and the cell range, which is B3 colon B77.
Edit. COUNT. Count left parent B3 B3 colon B7 7 B77 right parent.
And I'll press enter.
Sheet 1 table B79.
I'll check.
75 as formula B78.
So 75 is the frequency, meaning 75 cells under weight column have numerical values or numerical content. And I'll copy this formula to find the frequency under height.
C78 height.
And I'll paste the formula here.
75 as formula C78.
And NVDA reported the same value, which is 75, meaning there are 75 cells under the height column that have numerical values or data. Next thing is I want to count. I want to know if there are blank cells under each column, and I'll check. I'll go to A79.
Frequency count cropped A78 respondents. Blank cells overflowing A79.
Blank cells.
B79 weight.
So here under weight, I'm going to find the number of blank cells if there are any. So the syntax or the function is count blank and a cell range.
Edit. COUNT BLANK. Count link left parent B3 B3 colon B77 B77 right parent.
And I'll press enter.
Sheet 1 table B80.
I'll check by pressing up arrow.
0 as formula B79.
So there is no cell under weight column that has no numerical value. So meaning all of these cells under weight column have numerical contents or values. And to check also for height, I'm going to copy this formula.
C79 height.
And I'll paste it here.
0 as formula C79.
Again, NVDA reported 0, meaning there's no blank cell here. With, no cell here is blank, meaning all of the cells have a numerical content. Okay, next thing that I'm going to find is the arithmetic mean. I'll go to A80.
0 at blank cells cropped A79. Arithmetic mean overflowing A80.
Arithmetic mean is simply the average score or average of the given number of data. Now, by definition, this is found by finding the sum of the data and dividing it by the frequency. So in this case, we add all the data under weight and we divide by 75 since the frequency is 75. But Excel has a quicker way of doing it, and it's by using the average function. So I'll go to B80.
B80 weight.
And I'm going to input equals average and the cell range.
Edit. A V E R A G E. Average left parent. B 2 2 3 3 colon B 77 B 77 right parent.
And I'll press enter.
Sheet 1 table B81.
And I'll press up arrow to check.
56.87 as formula B80.
And the mean or the average weight of the respondents is 56.87, and this is in kilograms. So the average weight is 56.87 kilograms. I'm going to copy this formula to find the average height of the respondents.
C80 height.
And I'm going to paste it here.
158.39 as formula C80.
The average height of the respondents is 158.39, and this is in centimeters. So the average height is 158.39 centimeters. Next is to find the median. Median is the midpoint or the middle score in the distribution. So I'm going to find the median of both height and weight.
Arithmetic mean crop A80 respondent median 81. B81 weight.
So here in B81, I'm going to find the median of the weight of the respondents, and I'm going to make use of the median function. That is equals median, MEDIAN, and the cell range.
Edit. MEDIAN. Median left parent B 3 B3 colon B 77 B77 right parent.
And I'll press
median
enter.
B3 colon B77. Sheet 1 table B82. 55.00 as formula B81.
So the midpoint or middle score or middle weight here is 55.00 kilograms. And to find the middle height, I'm going to copy this formula
C81 height.
and press here, paste it here.
157.48 as formula C81.
And the median height is 157.48 centimeters. Now next is I'm going to find the mode of the distribution.
Median 81 respondents. Mode 82. B82 weight.
In B82, I'm going to type the function for mode, which is equals mode and then the cell range.
Edit. MODE. Mode left parent B 3 B3 colon B 77 B77 right parent. Sheet 1 table B83.
And I'll check by pressing up
60
arrow.
as formula B82.
60. So the most frequent weight is of the respondents is 60 kilograms, meaning there are many respondents with a weight of 60 kilograms. Now next is I want to find the most frequent height in the distribution. So I'm going to copy this formula
C82 height.
and I'm going to paste it here.
152.4 as formula C82.
So the mode or the most frequent height is 152.4 centimeters. Next is I want to know how many respondents have a weight of the mode, in this case 60. So how many respondents weigh 60 kilograms, and how many respondents uh, have a height of 152.4. That's the mode height. So I'm going to
Mode 82 response. Mode count overflowing A83.
I'm going to find the mode count. So I'm going to go to
B83 weight.
B83, and this can be found. Now I can find the mode count using the count if function. Input count if, again that's equals count if the cell range, which is B3 colon B77, and I'll put a comma after the cell range. I'll put a comma and I'll put B82 as the cell reference for the mode, since I computed for the mode and it is found on B82. Again, the formula has equals count if, then the cell range B3 colon B77 comma space B82. So I need to put B82 there because I'm looking for the number of cells that has a value of 60, since the mode is 60. And I'm going to input.
Edit. COUNTIF. Count of left parent B3. B3 colon B77. B77 comma space B82. B82 right parent. Sheet 1 table B84.
And I just press enter and I'm going to check.
7 as formula B83.
7. NVDA reported 7. This means that there are 7 respondents having a weight of 60 kilograms. I'm going to copy this to find the number of respondents with a height of 152.4 being the mode of the distribution.
C83 height.
Here I'm going to paste the formula.
6 as formula C83.
NVDA reported 6, meaning there are 6 respondents, 6 people with a height of the mode equals to the mode, which is 152.4 centimeters. So with this, I'm done with the measures of central tendency. Now I'm going to find the measures of variability. I'm going to begin with the variance. Now the variance is defined as the square of the mean deviation, meaning the difference of the mean and each of the data or each of the scores. Okay. So to find the variance, I'm going to make use of the var a or the var function.
7 as formula B83 weight. Mode count crop A84. Variance A84. B84 weight.
So here in B84, I'm going to input equals var a and the cell range.
Edit. VAR A. Var left parent B3. B3 colon B77. B77 right parent.
I'll press enter.
Sheet 1 table B85. 165.6306 as formula B80.
And the variance for weight is 165.6306. And to find the variance for height, I'm going to copy this formula
C84 height.
and I'll paste it here in C84.
79.04196 as formula C84.
And the variance in height column is 79.04196. Next is to find the standard deviation. Now standard deviation is defined as the square root of the variance. But here in Excel there are two ways to find the standard deviation. One is to make use of the standard deviation function, and the other one is to make use of the square root function. So I'm going to use both ways. First, I'm going to make use of the standard deviation function, which makes use of the syntax stdeva. Again, it's stdeva. It's like the abbreviation for standard deviation.
Variance A84 respondents. Standard deviation overflowing A85. B85 wait.
So here in B85, I'm going to find the standard deviation.
Edit. S T D E V A. Steva left parent. B 3 D3 colon B 77 D77 right parent.
And I'll press enter.
Sheet 1 table B86. 12.86976 as formula B85.
And upon checking, it's the standard deviation is equals, that's 12.8697. So it's the square root of the variance. The variance was 165, and the square root of that is 12.8697. Now to find the standard deviation of the height, I'm going to copy this formula.
C85 height.
And I'm going to paste it here in C85.
8.89055 as formula C85.
It's 8.89055. So this is the square root of the standard deviation, of the variance I mean. So now I'm going to find the square root, to find the standard deviation using the square root function. Now the square root function in Excel is simply the letters SQRT and the cell range or cell reference.
Standard deviation cropped A. Standard deviation overflowing A86. B86 wait.
So here I'm going to find the standard deviation using the square root function. So I'm going to input
Edit.
equals
SQRT.
So that the cell range here is B84 since the variance is on B84.
Left parent. B84. B84 right parent.
And press enter. And I'm going to check.
12.86976 as formula B86.
The result is 12.8697, which is the same as the result in B85. So either of these two ways can give us the standard deviation. So still I'm going to copy this formula
C86 height.
and paste it here.
8.89055 as formula C86.
And NVDA reported 8.89055, which is the same as the result in B85. So either of the two ways can give me the standard deviation. Next is to find the minimum or the lowest score or datum in the distribution.
Standard deviation crop minimum of 87. B87 wait.
So here in B87, I'm going to input the syntax or the formula in finding the minimum, which is equals min and the cell range.
Edit. MIN. Min left parent. D 3 D3 colon D 77 D77 right parent.
And
Sheet 1 table B88.
I'm going to check.
24.00 as formula B87.
So the lowest score is 24. That should be the lowest weight is 24 kilograms. That means the lightest person among the respondents weighs 24 kilograms. I'm going to check the height of the shortest person or shortest respondent. I'm going to copy this formula.
C87 height.
Here I'm going to paste.
140.00 as formula C87.
And it's 140.00 centimeters. So this is the height of the shortest respondent. Next is I want to find the other extreme, which is the max or the maximum.
Minimum 87, maximum overflowing A88, B88 wait.
So here I'm going to input the function which is equals max and the cell range.
Edit. M, A, X. Max left parent B. 3, B3 colon B, 7, 7. B77 right parent. Sheet 1 table B89.
And I'll check.
90.00 as formula B88.
So the maximum or the weight of the heaviest respondent is 90 kilograms. And I'm going to check the height of the tallest respondent. I just need to copy the formula here
C88 height.
and paste it here in C88.
177.00 as formula C88.
And it's 177.00. This is the height of the tallest respondent. Now the last measure is the range, which is the difference between the maximum and the minimum score in the distribution. There are two ways to find this. I can make use of the minus sign or the minus operation, the subtraction operation, or the other way is to make use of the combination of the functions, meaning I'll input equals max cell range minus mean cell range. So in this case, I'm going to input equals max B3 colon B77 minus mean B3 colon B77.
Maximum crop A88, range A89. B89 weight.
So here I'm going to input.
Edit. M, A, X. Max left parent. B. 3, B3 colon B. 7, 7. B77 right parent.
And I'll put minus.
M, I, N. Min left parent. B. 3, B3 colon B. 7, 7. B77 right parent.
And I'll press enter.
Sheet 1 table B90.
And I'll check the range for weight.
66.00 as formula B89.
It is 66.00, meaning the difference of the heaviest and the lightest person is 66 kilograms. Indeed, it's 90 minus 24, which can also give us 66. And I'm going to copy this formula
C89 height.
to find the range for the height column. I'm going to paste here.
37.00 as formula C89.
And the range is 37, and this is in centimeters. So the difference between the tallest and the shortest person is 37 centimeters. Now with this, I'd like to thank you for watching. I hope you learned something from this video. I just discussed and showed you some of the formulas and functions in finding measures of central tendency and variability, which are lessons in descriptive statistics. So thank you for watching. Until next time, see you, and God bless us all.